Okay, let's start. Hi, everyone. Sorry, my voice is not clear, but hopefully I'm not alone, so really, let's go. So we will talk about porting Tizen common to open source hardware devices. This is a community effort, and we've done this for maybe 1 year now, 2 years. So first, we explain what is Tizen common and what is open source hardware, and we'll show you 2 showcases about using this operating system on different hardware. So if you don't know about Tizen, the specific of this project, because Tizen aims to be the OS of everything, it has been designed for the 3rd version of Tizen that there is a common base known as Tizen common, and from each base you can create different products, which is, we call them profiles. This means you don't have the same feature in a mobile phone or on a TV. And at this time, Tizen common doesn't have some special profile logic inside it. This is just a common base. And for instance, Tizen Anavi is using 80% of Tizen common, and 10% as the IVI packages, special packages. Okay, and there's also profile of using it. What is important for this talk is that Tizen common is supposed to have a long-term support, so you're using LTSI kernel. This is a high version, but we'll try to stick it. And we have some feature enabled indeed. This is a security feature. And the system is for several architectures and several display configuration. We have a Hex 11 and a Wayland. AVI is using Wayland, for instance. So we want to provide accelerated graphics also on both systems, and provide architecture for running applications. That's what Kevin just explained before. And it's an inclusive platform. This means you can add any kind of libraries of toolkit you want to add, it will support it. But it's not provided by the platform. And what is open source hardware? It's, I'm sure most of you know what is it. But if you compare to open source software, it's quite similar. But you have some special things about the ability to create yourself open source hardware. This means you need the tools, because if you have the source, you should be able to make your things. So sometimes it can be difficult because it's a tough process. Why should I use open source hardware or focus on it? Because since same as open source software, you can just customize something which has been done before and focus about your special feature and not reinventing the wheel every day. And of course, there is a community who is giving you early feedback about the device, and you can fix bugs and maybe share the effort about making it running well. And last item, running open source software on open source hardware is making sense. If you want to have a system, you can ensure it will work and do nothing in your back. So let's give the talk to Leon now.
Okay, so we have 3 showcases for you. 2 of these showcases are about ARM, and 1 is about Intel. I'll share some details regarding the showcases related to ARM. Can you give me the point?
Oh, sure.
Okay. So the first showcase is about Sunxi devices. Sunxi devices are devices that has system on a chip manufactured by the Chinese company Allwinner. Sunxi has Linux Sunxi is the name of the community, which tries to support kernel versions and bootloaders for these devices with Allwinner's system on a chip. Approximately a year and a half ago, I started my efforts to port Tizen to these type of devices. Today, with the assistance of Philippe, we have Tizen common running on several devices. Here is the list of these devices. The A10 processors are single-core system-on-a-chip processors with Mali GPU. So the first board that the first board on which we ported Tizen was A10S or Linuxino Micro. This system on a chip is already deprecated. So here is the list of the boards that we support. These boards are manufactured in Bulgaria, and I'm really proud about this because I'm also from Bulgaria. And Tsvetan over there is the owner of the Allwinner company who are making these boards. These are open source hardware boards. You can find a lot of devices with Allwinner systems on a chip, but Allwinner is making open source hardware devices, which is especially important for community things. So the boards that you see here are with A10 and A20 systems on a chip. We have Tizen working on them. This is my personally favorite board, A20 Linux Micro. You can visit the GitHub page. There are some tutorials there, as well as links to download images. You can flash these images on a micro SD card, plug the micro SD card into the board, and get it running really quickly. The new devices that Allwinner, systems on a chip that Allwinner creates are A33, A80, and A83. We have them in mind. If you remember, yesterday, at the beginning of the first day, Hans explained the status of the Linux Sunxi project. The Linux Sunxi project is essential for the porting efforts of Tizen, as well because we are relying on the Linux kernel, which is available for these boards. At the moment, the kernel version is 3.4, and we are using U-boot. As I already said, there are images that you can download, flash to a micro SD card, and directly use. But if you want to build an image from scratch, these are the general steps that you have to perform. So the first thing is to get a bootloader. Luckily, the U-bootloader is compatible with these devices, and at the moment the mainline U-bootloader can be used. After that, you have to clone the Linux Sunxi kernel. This is a fork of the standard Linux kernel, which is available for Sunxi devices. There are a few things that you have to keep in mind. One of the things is that these devices are not using regular device trees. They are using FEX files, which are converted to binary files, but they have the same row, just like as the device trees. Once you have built the bootloader and the kernel, the next steps are related to building Tizen. So there are a couple of ways to build Tizen. As you heard on previous presentations in this room, you can use Yocto, but in my particular case, I'm using the Git build system. So with a powerful enough computer, you can build it, cross-compile it in approximately 4 to 6 hours. Then you have to, once you have all RPMs, you have to prepare a Kickstarter file and to create an image. The final step is to prepare a bootable micro SD card with a FAT partition where you should place the Linux Sunxi kernel and X4 partition for the Tizen stuff. So I would like to show you a couple of examples of device that you can create. One of the most important things in open source hardware is that this is a low-cost opportunity to create prototypes and to create them rapidly. So these devices are not entirely open source hardware actually, because the boards are open source hardware, but here this is a Motorola lapdog, so the board is connected to this Motorola lapdog. Motorola lapdog is a project which is not being active anymore, but you can find these gadgets in eBay in very reasonable prices. And the other thing is a homemade tablet. It doesn't have a case. It's something that we are thinking to do next, but it has a display with a touchscreen and a board attached to it. So we're moving to the second showcase, and this is it's called Tizen Rockchip. Rockchip is another Chinese company making systems on a chip. These are low-cost and powerful systems on a chip. Tizen Common runs on a couple of their platforms. RK3188, this is for the Radha Rock, and RK3288 for the Firefly. RadHarock recently became open source hardware project. It became on my birthday at the end of October, so I decided that it's the perfect moment to port Tizen to it. I had an early sample of the board thanks to Tizen experts. So here you can find information about the project as well as images that you can download. At YouTube there are a few videos that you can see Tizen command running on this board. I will not go into the details about the process for building Tizen Rockchip image because it's pretty much the same procedure as for Allwinner devices. The difference here is that there is a U-boot, but it's recommended, or at least that's what I've understood, to use proprietary bootloader. So the image that is available at the moment for booting Tizen command on from microSD card on the two boards that we support, these two boards, are using proprietary bootloader. There is a fork of the Linux kernel again. This is a fork for the Rockchip devices. For RadHarock we have Linux kernel version 3.0 and for Firefly we have 3.10. So it's the same procedure. The only thing that I had to fix was a display issue. So visit GitHub to learn details or contact me if you are interested in porting Tizen to Rockchip devices. I'll be really thankful if you have these type of devices and help me to test and expand the port of Tizen to more devices. So this is the third showcase. And I'm passing the mic to Philip, who will explain about MinnowBoard Max and Intel devices.
So the MinnowBoard Max is becoming popular. Many people show him in a different session at FOSDEM. So this is an Intel-based card. It's created by an American company known as Sunxi, and all the design are copyleft under Creative Commons share-alike license. And it's using Atom Bitrate platform. It exists in two different versions, one with a single core and the other with a dual core. And it features fully open source mainline support GPU. So this is very interesting if you look at graphics in the embedded world. You have something which is open source and already integrated into the kernel. And of course, we will have kind of expansion slots. And there are some feature which is interesting. They have some kind of daughter board you can plug on it, similarly to the Arduino shields. And so it's sort of like this. You can plug them over there. This one is providing extra input-output for managing analog input, and you have some other kind of stuff, and you can even design your own and provide them as open source hardware also. And for the software, as I said, it's supporting Linux kernel mainline. The firmware is provided by Intel as a UEFI project. This is one version has been released just a few days ago, if I'm not wrong. And Coreboot is making a lot of effort to support this board. So if you care about openness, I think this is a good target. And as I said, Tizen Common is running on it. This is one of our reference devices. So you have every feature of Tizen Common working on it. And you can even download the image we are building every day or every change. And just install it to the SD card, and it will boot, and you get the graphics and the web browser. Everything is running fine. And if it's not, please file a bug. And you can also create build your own image using GBS, like Leon explained, or just using Yocto, because this board has already support by the Meta Intel layer of Yocto. So normally there should not be some problem, but if there are, this is important for us to fix it, so please report some bugs. The small work I've done on this, I work on the boot system, and we are using EFI boot in Tizen. We are using GummyBoot UEFI firmware to boot it. So I think we're done with the MinnowMax. MinnowMax is a nickname of the board because the MinnowBoard 1 was a 32-bit version, and the second one, known as Max, is a 64-bit. So to prevent the ambiguity, I prefer to call it MinnowMax, because when we say MinnowBoard, people who don't know which one is it. So for the future, this is a community effort, so we don't have those deadlines, so we are somehow comfortable. But we like to be more connected to existing community, like Linux. All the MinnowBoard documentation is happening over there. And also to the Yocto project, which is providing support for it. I may be able to show some hacks around about IoT demo running on the MinnowBoard, about the IoTVT library, if you know about it. It will be at 4 o'clock in the IoT room. And I expect this to be very popular among hackers, makers, or people who care about graphics, because the support is good. So for the future, about this project, we probably plan to port Tizen command to all kind of board. Those we are able to buy, actually.
Yes, we're interested in getting Tizen working on as many boards as possible. So we'll try to get it running on more ARM boards. For sure, Freescale IMX6 is among our targets, Galileo 2, and OMA platforms, as well as newer models of systems on a chip manufactured by Allwinner and Rockchip. We're particularly interested in these devices because of their low-cost prices. We are facing a few challenges with the ARM devices. They're related to the GPU drivers. Most probably you have heard that the majority of these drivers are proprietary. The boards that we support at the moment, Allwinner systems on a chip and Rockchip, are with Mali drivers, and we are searching for appropriate Mali driver for Wayland, because Tizen Common is relying on Wayland, although there is an opportunity to use it with X11. We prefer Wayland, as this is the future.
I think we're done.
Just to mention that we are also trying to get more peripherals working on these devices as well, because this will be a good opportunity to use Tizen in the Internet of Things more and more.
Or create your own profile. It's your imagination. So let me present you. This book was written by Leon, and I review it. And it has a whole chapter about building Tizen on, it was 820
yeah.
or
810 and 820.
So there are some discount code if you want to, it will work, I think.
The main focus of the book is on application development on Tizen, primarily HTML5 apps, but it's possible. The last chapter contains information about porting Tizen to different hardware.
And we shared some resource for you if you want to later have some entry point about getting the stuff done. And now we want to thank all those people. And if you have some question, we can answer them now. And if you don't, contact us later. We'll try to provide anything you need.
Just to mention that the presentation is already available at SlideShare, so you can check the links there. It will be uploaded at the FOSDEM website as well.
You're right.
Any questions?
Hello. Sure.
To work around the driver issue, could you do the same thing as we have in the Surface presentation yesterday and use these libraries?
We plan. Okay, I repeat the question for the recording. About the driver issues, the workaround could be to use live libraries to rely on a vendor BSP and try to bind this to the software. We have a different approach in the Tizen project because it is supported by hardware industry, and we have it's a full GNU Linux distribution. We don't want to rely on some hacks and having a hybrid system, but Selfish could be an option, and I've seen some proof of concept of Tizen running not on live libraries, but similar kind of adaptation. if I don't think it does matter for open source hardware to have to rely on Android BSP. Any more questions?
For developers to develop the apps for such boards, it's important to connect the debugger from the SDK or to connect the SDK using the SDB. Traditionally, it's done using the USB port, but as far as I know, the MinnowBoard doesn't have the USB client.
MinnowBoard has a USB, 2 USB slots.
Yep, but that's the USB host side. Yeah. And to connect the board to the PC, you need the USB client.
I think it's possible, but I will not answer you. I will give the microphone to the MinnowBoard specialist.
So you are correct. The MinnowBoard Max does not have a USB function or OTG port directly on it. However, there is a Lure in the works that has that daisy chained off the PCI Express lanes. So it's coming. It's not out yet. I have a prototype sitting on my desk at work, so it's not just vaporware. I do not have, no, my office is in Portland, Oregon. Okay. So, so sadly, I can't just show it to you, but it is not vaporware, it is coming.
I just wanted to add that the Smart Debug Bridge, which is used to debug applications on Tizen, can be connected over the network. So this is also an option to debug it. Yes. Okay, last question. Anyone? Okay, thank you very much for your time. It was a pleasure.
Thank you very much.